So extremely sorry for being late. I was caught up in the train. The train didn't come on time, even though I was working. Sorry for that. But I hope this will not happen. So nice to see everyone in person today. The first two lectures were on Zoom, and I wasn't able to make it to those classes. Nice to see you guys and Vilya. Vilya is our TA. We have two more TAs. They're not here. Okay. All right. So for us to talk about AI, it's very important for us to talk about data. And why is data that important? The reason with data being so important is that 80 to 85% of the work we do with artificial intelligence is actually the work we do with data. You have to work with data to be able to build your models. And that's the difference between simple application and an AI application, is that you start working with data in AI first, whereas a normal application, you jump onto the software development first. So two of our lectures will be focused on data, and we'll just talk about data. So I'm actually recording the class on Zoom too. Okay. Okay, so let's talk about the steps we need to identify an AI system. So what do we do when we want to work with AI? It's very like simple steps what you do. The way we work with AI is like, first of all, I mean, there's always a problem, right? You have to look at the problem, you have to identify the problem. Once you know what the problem is, you start to, instead of jumping onto working with coding it, you then start looking at the data. So you know what the problem is. The problem can be as simple as you want to predict the temperature for tomorrow. And if the problem is as simple as that, you want to see like it's going to rain, or if it's going to be sunny, then the second thing you want to do is to look at all the data available historically. Now, historical can be hourly data for the last day, or it can be a daily data for the last week or a month or a year or so on. But you need that data. And if you don't have that data, you cannot go to step 3. So step 2 is very important. Then step 3 is the regular programming. You choose the algorithm, and once you have chosen the algorithm you want to work it with, you know what algorithm you want to use. You then train the algorithm. You then train the algorithm with the data you have, and then you just run the algorithm. Now, training number 2 and number 4 are new for you. Number 2 is like looking at the data, and number 4 is training your algorithm on the data. This is a very AI specific thing. You don't do this with any other software development practice. So that's why AI is very expensive to work with, and you need GPUs to be able to train your models. Because when you have a lot of data coming in, the model needs to understand what the data is, what's the pattern in the data. If you want to predict what will be the temperature tomorrow, the model has to see how was the pattern evolving last week or last month. And you need to show the model all the data. And data is pretty huge. Data is like, on good working models, data can be like millions of rows. And when you tell the model, like, this is the data I have, the model will make its own understanding based on the pattern in the data. The bigger the data set you have, the better the model will understand from your data. And that's why ChatGPT is better than other LLMs, because they have been able to train ChatGPT on huge amounts of data, like 40 billion parameters and so on. Yeah. So if you were to show how general software development is different from AI-based development, this is how it will be. So in a general software development, what you do is you start with the programming part. You create an application, and then you generate the data at the end. Like, you're also making a database application, but the data will be generated all the way to the end. But in an AI-based application, you do a repetition in the whole step. You have an input data, you have an output, the data you need, you make the application, you get the desired output, But you don't really stop over there. This is also another complexity with AI. In a general software development, once you're done with the application, the next step is fixing the bugs. In an AI application, you don't really have bugs the same way. You look at the desired output and you're like, now you're controlling the algorithm and you want to improve the output. So you go back and you fix the data and you train the model again, and then you go back, and this cycle keeps on going. So there's like in software development, there's a field called DevOps, where you focus on development and operations. In machine learning, you have a field called machine learning ops, which is focused entirely on this circular loop. How you improve the model, how you deploy this into production, how you monitor the model, and so on. Yeah. Has anyone tried Kaggle? Kaggle is, if you have not, take a look. Hugging Face, you haven't tried Hugging Face? Okay, few have. So these two repositories, so these two websites are pretty good, Hugging Face and Kaggle. Take a look at them. They'll give you an idea on, they have like a combination of all the algorithms. If you want to start working with AI, they will have a go-to guide on which algorithm you should start with. They already have prepared data sets, and you can start working with any AI algorithm over there. Now, in the concept of data, this is something, I don't know if you have seen this, but this is kind of something which the world keeps talking about. The world keeps talking about data as being the new oil. They say like data is the most valuable resource in the world. And there's so much, anyone who owns the data will own the next billion or trillion market. And that's true, because take a look at Facebook, Twitter, and all the social media platforms, or any application which you use on your phone, and you know your friends are also using that app. Even though those apps are free, the way they make money is based on the data which comes to you. And data is becoming, data is actually so important that now with the rise of AI algorithms and this ChatGPT and all these companies like Twitter, Reddit, and a few other social media companies which were previously exposing their data for free are now charging for their open public data, because they know their data can be used to train all the AI algorithms. So the Norwegian government says that all offently companies should actually expose their data free of cost to everyone else. You think I can?
It's problem with the door. Okay,
Yeah.
that way.
Okay, I see.
They're trying to.
Yeah, I guess we can just live with the noise. It's not a problem. Thank you for helping out.
We managed to open the test.
It's all right.
Not open this door and the.
Oh, so they, oh, okay.
It's only this one, so that's why people.
Okay. I thought students were leaving, so they were just moving.
Yeah, they're
Okay.
just moving to the other place. So
Okay. It's all right. We can live with the noise. Yeah. I hope the person comes back. Yes. I'll wait for it. All right. The last IT minister which came up in Norway, I don't remember his name, but so not him, but the Norwegian government announced at that time that every state company should actually open their data up, make the data sets available for everyone else, and they should share their data and information. So what happened was that obviously all state companies agreed. They were like, yeah, we need to share data, but this is a directive from the Norwegian government. We need to follow it. And we started sharing the data. And what turned out was that all the private companies around the world, they started using our data and started preparing applications, and they started sending those applications back to us. And then the new discussion started, like, Okay, this discussion is going on. We don't really have any conclusion on this one, but the discussion is like you have the data sets which belongs to the Norwegian population. You make it available for free to other companies who build applications on top of that one, and then they're selling those applications back to us. Is this the right flow? And is this the right way it should work? And there's no good answer for this because as a Norwegian, um, as a public as a public company, you are supposed to make everything available for free. But it's very hard to control how that information or data is being used and sold back to you, like Google Maps or Apple Maps in that sense. So if you look at the daily life of an AI programmer, you can safely assume like 80% of the time is spent on data. You work with data cleaning, you work with data transformations, you work with analyzing, labeling, and so on. Around 15% of the time is actually spent on AI programming, and 5% is spent on deployment and all that. So if you want to be a good AI programmer, be a good data engineer first. You need to know how data works, and then you can work on that. So okay, I don't know why I have this image, so I'm gonna skip on that. Yeah, this is a typical kind of job description for an AI developer. They are looking for okay. The profile of an AI programmer is a person who can do statistics, a person who can do machine learning programming, but that would be 5 to 15% of the job, right? The remaining 80% of the job is actually a software programming job. Because once you have, if you want to work with the machine learning applications, you need to know how to work with data. And data engineering means that you need to know Python programming language. You know how to load data into your application, do some transformations, and then load it out. Once the application is done, you then need to deploy this to a server. You then need to monitor the application. You need to talk with other programmers, and then you need to integrate it with your app. You need to integrate it with your backend system and so on. So the profile of a machine learning programmer is a programmer, a basic programmer who can do basic programming stuff, but can also have an interest in doing machine learning or can already is doing something with machine learning. There was a very famous tweet some years back where Tesla was looking for AI programmers, and what the head of the AI at that time said, like, okay, if you are a good software programmer, come to us. We are looking for AI developers, and we will, even if you don't know AI, we will teach you AI. And I think that was a very spot on thing to say, because at Ruther, we do the same. We look for good programmers. And if someone has an interest in AI, good. If not, then we can also teach it, because we think AI is not really that overly complicated. And if you have an interest, you can go in that direction. But you should know how to work with data, and you should know how to work with software programming in general. Okay, let's talk about issues with data. So data pitfall means the issues which can happen with data. And when you work with data, the most basic problem, the most basic thing which comes with everyone is that everyone assumes data will be clean, and data is not clean. So if you are trying to build an application which predicts the postal code or predicts which area you're going to be living in, you need a lot of addresses for people. And this is an example of the spelling mistakes which can occur in all the lists of addresses. If you are looking at the temperature application and you want to build an application which predicts it's going to rain or it's going to be snow tomorrow, I can guarantee you that all the weather information you have uploaded, there would be problems with that input, and you have to go through all of that or have a script which cleans all that information for you. Another real world example would be passenger prediction. Like the buses which go around, We need to predict how many passengers will be there in the bus tomorrow or in the next hour. So we take the data coming from our own sensors inside the buses, but sometimes the sensors can be faulty and be giving the wrong data. And if you use that wrong information and give it to your algorithm will give you a wrong prediction. It's very important to make sure your data is clean. And cleaning takes a huge amount of your time because you don't really know how much data is wrong or bad in your data. And if you give the wrong data to your algorithm, it will be a wrong prediction. Yeah. What's an outlier? So outlier is something which doesn't really belong. You have a statistic set of data or statistic set of population, and you have something odd coming in. Cancer is an outlier. You have the functions, the body functions in a specific way, and then you have a cancerous cell which comes out of nowhere and starts making affecting the body. Cancer is an outlier. If you create a web application, and as soon as you launch the application, you have a script which is monitoring the application and seeing how many people are accessing your site every day. And immediately you see like, oh, you have like 100 users coming into your site every day. You might be happy, but on closer inspection, you would find out that these are bots who are just like crawling around the web. So that traffic is an outlier for you. You cannot include that into statistics for your application. Sometimes you need to exclude the outliers. Other times you need to include the outliers. So excluding is something which we just agreed, right? What's the kind of data set you should exclude? What is including? I can't come up with a good example of including 21 people using the product 1,000 times a day. I need to come back to this including one. This is important, but I'll come back to this. I can't come up with a good example. Seasonality is very important. Like certain things happen in a specific way. We go to work every day. We go to school every day. We have a specific pattern, but something happens like you always have a pattern. Like you have the working days, you have the weekends, and then you have some holiday coming in. Nothing is happening over there. You have So what we do every day is a standard thing, and everyone accepts that. You have a 7-day working week, but you have like summer vacations. Everyone accepts that everyone is away in July, but then there are certain things you don't really control. Easter changes every year. You don't have a specific date for Easter. Black Friday, you know exactly when it's happening. So what I'm trying to say is that there are certain events which change every year and you don't really have control over them. And when you ignore those things in your data and you suddenly see a spike in your data, for example, we work with passenger data and the passenger data looks very normal over the time. And on the rush hour, it goes up, low time, it goes down and so on. But on Black Friday, it spikes. And we all know why it's spiking because people are going to the shops and they're buying stuff. And it's like an irregular pattern. But that's an abnormality in your data. Black Friday is an abnormality which will happen once a year. So you have to you have to identify that abnormality and you have to tell your model that this is an event which will happen every year on this specific day. Easter is hard to predict, so that changes. Can you give me an example of something which was an abnormality? Yeah.
The football game that was here.
Yeah. Okay. So what happened with that one?
No, like a football game, and I ago, I think.
Yeah.
So a lot of people just came in at like late hours,
Yeah.
around 6 to 7. So that I think.
That was a very big, you're right. Yeah. Any other example? Yeah.
People checking their taxes, tax returns.
Yeah. Then you have a spike in the traffic, correct?
Christmas time?
Nobody's leaving, correct? Christmas time.
COVID.
COVID, yeah. That was a good example, COVID, because COVID is something which happened once, and it was a generational thing. Like it's something which happens in one generation and might not happen again. Now, this is an abnormality which we hope is not going to repeat. But if you look at from a data and statistics point of view, COVID was once in a generation thing. Now, how do you control once in a generation thing? Wall was also once in a time frame thing. Like you don't have it happening all the time. Christmas happens all the time, for example. So you have to treat these three instances differently. Like we know that our algorithms messed up really bad in COVID time. All of a sudden there was a drop in traffic. No one was taking the train or the bus in Oslo or Weekend anymore. And rush hour was gone, off-peak hour was gone. We were used to working like this. We were already working like that. And then we had an AI algorithm which was used to working with the data. So we had to teach the algorithm the new reality. And that was a very hard thing to do. And now we have to teach it again. Now you're back to the same environment because now we're back to the rush environment and the peak and the off peak. So seasonality is very important. This is called seasonality. When something changes, you have to incorporate that. And context is critical. A very good example for that would be you again launching your application, and all of a sudden your friends are on your website, your parents are on your website, and they're buying stuff on your app, on your website, and you're extremely happy that there's traffic on your website. But the context says that those people are supporting you, so it's not really an organic growth for your application. So once that support is gone, you actually need organic growth. You need people who recommend each other to come to your website, who just search for your website. So context is extremely important in looking at data. If you want to see the number of users, if you go to investor, you tell them like, I have 10 users who have been buying stuff on my website. I want you to invest on it. The user wants to see where the investor would like to see where the users are coming from. If the users are coming from your family, then it's not really the right context. But if the users are coming from around the world, then yeah, there is some value to your business and the investor would like to invest in that business. I came in late. I don't know when the break will be. Normally we have a break at 9:15. You know what? How about we take a break at 9:15? We have 5 more minutes. So let's, So it's one thing to have data, and then if you don't have proper insights to your data, you don't really know what the trend is. We as humans are very good at looking at thousands of lines of text, or 100,000 lines of text, and we can identify a pattern. But as soon as it gets like millions of entries, it gets extremely hard. Have you looked at a stock price information, a stock price graph? Most of you probably have. If not stock price, feather information, it shows you a graph as well. Now, there's a way to export that data as well as text information, and try to export that data and see how many millions of entries are behind it. For us, it's impossible to see all those entries. So what we do is we make graphs, we make charts, and those give us insights into our data. So when you work with data, and you will learn this in a few labs as well, we're going to show you how to work with data, what kind of graphs you can make. You need to make those graphs to be able to see what's happening with your data. These are kind of the insights you will, this is a very advanced thing. You won't really do this. But Python is very, very useful. Python can make graphs like this and that, like very quickly by a single line of command. Okay. Now, how should you work with data? So the previous was like the issues with the data. And now we're going to talk about how you can work with data. There is no formula behind it. There is no framework behind it. There is no guideline. This is just the things we identify in a specific problem, and we start to fix those issues. The most important one, or because this is used a lot in supervised machine learning, is called data labeling and data annotation. There's a field of artificial intelligence which is called supervised machine learning. And there's another one called non-supervised machine learning. And then there's called okay, but let's talk about supervised machine learning. So what supervised machine learning means is that you need to train the model like a child. You want to tell that this is good, this is bad, this is a dog, this is a cat. This is how you train the model in a very selective way. And you have a set of instructions. So let's not go that way. Let's talk about images. You're making an algorithm a very easy algorithm, which will identify between a cat and a dog. You point your camera and the algorithm will say if you're pointing to a cat or if you're pointing to a dog. Now, that kind of algorithm, let's say you decided to make it a supervised machine learning. That algorithm needs you to upload 100 images or 1,000 images or 1 million images, you choose, but you need to carefully label them as cats or dogs. You need to train the model by telling it, okay, these 50 images are cat images, these are dog images. So once you have given those examples, the model will then say, okay, now I think this is a cat or this is a dog. So that was one example. Labeling is something, what labeling or annotation means is you look at an image and you give certain values to it. It can be as easy as looking at that image and telling if a person is happy or sad, person is wearing a tie, if there's a dog in the image or there's a water cooler behind it. Or like that. This is an example of how labeling is done in driverless cars. You have Tesla, you have Audi, Volkswagen, all these driverless car companies. They have a continuous stream of video going in and someone is sitting down and building like blocks around it and all that. So, so what happens in labeling is that you have a person, this is a very manual thing. You have a person sitting in front of the images, front of the videos, and they draw a rectangle around it or a triangle around it. And then they do it to the second image and the third image. It's a very boring process. It takes a lot of time, but this is how we train the AI models. This is the most stupid way to train a model, but this is the most effective way because this is how the models actually perform very well. Even ChatGPT, not like this, but it also uses a lot of label data. It is estimated that if you're working with supervised machine learning, around 25% of your time is wasted on data labeling. And this is where my company found a business opportunity and we made a data labeling company. So we have a data labeling company which provides data labeling services, and we are doing very well because we have a lot of people who label data and we give it back to machine learning programmers. Okay, this is supposed to be a demo, which doesn't really work. I think I'll send you a link afterwards. But in this demo basically shows you how a driverless car annotation works. So this is same for Tesla, Volkswagen, and everything. Yeah. Do you know what a LiDAR sensor is? Yeah. Okay, for those of you, some of you know, for those of you who don't know LiDAR, the new cars which are coming out, the electric cars are coming out, they have a lot of sensors on top. The way they detect where to go or not are because of those LiDAR sensors. They are called LiDAR sensors. So they can see through buildings and they can try to map out how the whole infrastructure is. So their range is very good. And they collect all the data back in, and then they see like, okay, this is an object or pedestrian, and I need to walk around it. LiDAR is very important when it comes to driverless cars. This is what they rely on. Let's take a break, 15 minutes, and we come back. All right. So let's start. Come back to the class, everyone. So when you were talking about data labeling before, the second kind of thing you can work and fix with data is called data anonymization. What does anonymization mean? Anonymization generally means when you're trying to hide something, protect something, you anonymize it in a way that people cannot see the way it looks. So in data anonymization, what you do is you look at the data as a single source of truth, and you try to create another source of truth, which would be, it wouldn't be a copy of that, but something entirely different. For example, in this example in front of you, you have taken a piece of information, you have changed the ID, you have changed the name, you have changed the email, you have changed the phone number, and you have created a new entity around it. Now only you know that this entity is actually that one. In certain organizations, this thing is used quite a lot. In Skatetaten, we were using this when you call on a customer service, or you have certain not on customer service, but when you send a case or something, in certain instances, they're not allowed to see your name, your gender, your background. They only see your social security number, so they anonymize a lot of information. So you don't really know who the person is calling, and who the person has sent them the message about, and they try to give you like a fair assessment. Now, there's another reason why this is becoming more important, and that's because of GDPR. Has anyone heard of GDPR? A few have. I'll give you a very quick introduction of what GDPR is. How many of you have seen those pop-ups coming up on your site when you visit them, and they're like, "Are you okay with cookies or not?" Yeah, almost every one of us has, right? Because we use them on a daily basis. Now, the reason those things came up, those cookie pop-ups are coming up, is also because of a directive from GDPR, which says that the data of a person, data of individuals should be protected, and how you collect data for a person on your website should be shown back to the user. And that's why the websites are asking you, are you okay with us collecting your data, because we're collecting your data in this and that way. So that has created a lot of complexities for companies who work with personal data. I'm again going to quote our company, Router, who works with personal data. And the problem we faced was that when you have a mobile app, everyone has a profile. So we were not allowed to use your personal information to train our algorithms. So one workaround we were thinking was to anonymize your information, create a new entity around it, which is not connected to anything else in the system, and then use it to train the algorithms. And then instead of a person knowing who you are, we encrypt that information with an encryption file, and that is stored in a local server somewhere inside Router. This is one way we are thinking on how to fix a GDPR issue. And the reason it's not really GDPR, it's mostly due to how you expose your citizen information outside of Norway, because the data should not be placed in servers in US or anywhere outside Norway. Norwegian government is very strict on that kind of information. So data anonymization is used a lot when you have secret data, sensitive data, and you want to hide it. You don't want to expose it to anyone else. You use a lot of data anonymization there. Synthetic data. Since AI needs a lot of data, there are instances where you cannot find enough data. And what people have started to do was to generate artificial data. And that artificial data is called synthetic data. Let's say you wanted to generate a list of names, and you as a person, as a human, you can come up with certain number of names, but your model needs around 1 million names. So what you do is you have a lot of algorithms already available. You use those algorithms to generate random names. That would be like 1 million names, which will be randomly generated, and that would be synthetic data. Why do we do this? Why do we make synthetic data? Because the problem is that there are many issues with your private personal data. You can generate a lot of data personally in your company. As a person, you have phone, you have a watch, you have a lot of smart devices, you can collect that data. But then the problem is how do you transform that data? How do you make that data available to your algorithms? And you need a specific standard. So they spend a lot of time transforming the data according to the standard you need for the algorithm. So it becomes very easy with synthetic data. What you do is you just tell the algorithm, I need this data, and I need it in this format from my algorithm, and the algorithm will just generate it. The chances of error are also very low because the data is clean, it's already curated by the algorithm. And yeah, so it's good. It's used a lot, but can anyone identify a problem which could happen with synthetic data? Like you can get a lot of data from synthetic, but there can be issues with that. So yeah,
That data has to come from somewhere, and if it's generated, you don't have necessarily control over what kind of database that's generated from.
okay, that's a very good answer. So the way, and I'd like to extend it by saying that you're right, you don't have control over how the data was generated, because the algorithm is also controlled. You tell the algorithm, I need data this, and that way. Now, this is a data you are controlling, and you as a human can only think in your context. When you use random data, you allow the algorithm to find the patterns in that random data. When you use a data set of millions and millions of people, there are things we cannot control. There are faces we cannot imagine. There are shades of the color skin we cannot imagine, which gets picked up by the algorithm. But when we are generating, let's suppose I am generating a set of images and I tell the algorithm, generate these images, I will think about color black, brown, white, right? Colors I'm used to. I'll think about names I'm used to. I'll think about shapes I'm used to. But people are more than that. So that's the problem with synthetic data. When you generate synthetic data, you only generate a data set for a certain population, and that's not predictive for your special case. When you collect data from a production application, any application, you actually get random data, which is useful. It's expensive to work with random data because then you see all sorts of problems. But that gives you a very good prediction because then you see everything. So this is a design decision you have to make. Should you rely on synthetic data? It's cheaper to work with. It's effectively available. It will work immediately. It will have less errors. Or should you go the hard way and collect all the data and transform it and make it available for your algorithm? Yeah.
Is there a middle ground? Like you like combine those two? Or is there really like
They do, yeah, Skatataten is doing that. I know.
Okay.
They're using a lot of, they're generating a lot of synthetic data, and then they're using natural data as well. It entirely depends on you, the use case, how it works.
Like train your algorithm to create the data based on the private data that you have. Make it like as close to the private data as possible.
Yeah. Let's take ChatGPT as an example. So ChatGPT is trained on multiple amounts of data. One of the data they trained it was synthetic data because that was generally available, but they used a very small portion of the synthetic data, and then the remaining data they produced was a one coming back from human interaction, because they then realized they can't. I mean, you can't just, for an application as big as ChatGPT, you need to have control over what kind of data sets you use. So there are multiple sources used. Yeah. This is an example of how you, the way synthetic generator is generated is that you have to give it some kind of input as an original data, and then the algorithm looks at that original data and generates much more synthetic data for you. So another way to work with data is through, it's called data preparing the data. It's like cleaning the data and feature engineering. So feature engineering is very important. What it means is that you look at your data and you're like, okay, this is my data, but this is an attribute of the data. This is something more I can get from the data. How should I explain this? Take a look at this image. Immediately, you know what kind of image it is. It's an image of a car, and you know it's a Tesla car, you know it's a self-driving car, and so on. But if I were to give you a task and I ask you, like, identify a few features of this car, and now you're looking at the image and you're trying to identify different features of the car. A feature which would kind of point out for this specific image would be the color. Color is a feature of the car. Then you would look at how many tires it has. That would be a feature of this car. You would want to see if it has a what kind of roof it has, for example. The image cannot tell you if it's a self-driving car or not. We know it's a self-driving car, but the image cannot really tell you. And one of the features is there's like Tesla logo over here. This is called feature engineering. When you look at your data and you try to define some certain features, and using those features, you can relate to your data point. Now, if we go back and the features which we decided, which we discussed right now, if we just focus on the features and we say like, okay, we blank out the screen and we talk about the features only. We talk about the feature which was like 2 mirrors on the side. We talk about features, 4 tires. We spoke about feature having a color red. There was a logo in the front. We can develop an image in our brains that we are actually talking about a car. Not exactly a car, but there are certain features which we are talking about. This process is called feature engineering, and this is heavily used in AI application, because when you use your data, the multiple features you create are an information about your data to the algorithm. So you tell your algorithm, like, this is the data set I have, and these are the features it has. In certain applications, the features can be a few, 5, 10. They can go on to be 1,000. They can be millions, and so on. Features are also called like parameters. Okay. In a if let's say you're making a character recognition algorithm, and you want to make an algorithm which identifies if it's a plus sign, it's a minus sign, and if it's a division sign, and so on. So the features could be actually how the sign is organized, how many dots are there, if it's a plus, if it's straight line, or it's a minus sign, for example, that could be a feature. If you are working with speech recognition and you have a data set of audio, then the features could be the length of the sound, how many spikes, how many times the person says, for example, and the pitch of the sound, that could be a feature, and so on. If you are working with a spam detection algorithm and you're looking at emails, so email is the data sets, all the emails are data sets. The features could be frequency of certain items, how many times a certain item is being repeated. If the grammar is correct or not, that could be a feature. And the structure of the email, how many times did you use caps, or if it's a small one. Now, all these features, you cannot just automatically detect them. So every feature means that you have to build a script behind it. So if you are building a feature which says like, if you need to check the grammatical correctness of the email, you have to build an application which looks at the data sets and filters all the emails which have a specific error, or filters all the emails which have a certain email header in them, and so on. So every feature means every application being built. If you have 1,000 features, you have to build 1,000 applications in your data. Okay. So inside address information, the features can be like address, city, state, zip code. These could be like features. If you're looking with if you're working with time series, the feature could be year, month, date, if it's a holiday or not. Yeah, so on. So then how do you extract a feature? This field is called feature engineering. And feature engineering was as simple as me showing you the car, and then I asked you like, okay, identify 5 features from that one, and then every one of you will have a different feature, because I mean every one of you looks at the car in a different way. So every one of you might say like, you might all have the same features. You might all say like, we identified 5 different features. No one will have a wrong answer. But it's very important to distinguish an attribute from a feature. An attribute is something you see immediately, but a feature is something which is a combined information from the data set. We'll cover that more. So if you have consider these 2 patterns. You have these 2 patterns in front of you. Very simple patterns. And if I were to say like, make features from these patterns, it makes no sense, but you have to make a feature from that one. So you make 3 features from the first row, and then you make 3 features from the second row. And it's as simple as that. And you can make more features out of this one, the way you think, the way your creativity works around it. Yeah. This is a very good example. Quora, have you used Quora? Quora is something which is, yeah, question and answers. So let's say you're doing, I asked you to make features from, I asked you to take all the question and answers from Quora, and I'm like, there are questions and there are answers on Quora, and I asked you to make a feature set from those question and answers. So, and like Quora, you have a question, you have an answer, you have a good answer, you have a bad answers. So for you to be able to identify a good answer, you need to see why this answer was a good answer. And then you're thinking about, If it was truthful, it was reusable, if it provided the right explanation you needed, yeah, and the format was good. So the features which could actually come to you from a core answer is how many votes did it get? That would be a feature. If the person has a special experience in that field or not, and the structure itself. So these could be the features you could extract from, yeah, from your data set. Right. So features typically go before the modeling part. Once you have the data, you clean the data, you make it available, you label the data, you then put features on the data. You tell the model like, okay, I have the data is prepared, data is labeled, and I think the data should have these, this, and that features. Then you give it to the model, and then the model now knows it's labeled. Those features are there. Now it has to work with it. So, I mean, another image of which kind of shows you that feature engineering is very important for the model. Right. Another example of how to create good features is this is a tabular data. This is the kind of data we normally work with in our daily lives. Like what kind of data I work with most of the time. We don't work with images, we work with text. And this is the kind of text that data you get. And let's say that you have to make features out of this one. The information you have is like the client ID, you have the time, you have the date the person joined, you have the income of that person, and then you also have the credit score of that person. And then your task is that you're supposed to create some more features out of this. Can we create some? Can you give me an example? Yeah.
I guess the credit score above a certain threshold,
Okay, yeah, good. Yeah.
or the year the client joined.
The year, the client, yeah, because you have that information, correct? So you can have a year, you can have a month, you can have a day as well, I guess. Yeah. The mean of the credit score. Yeah. You can even have an average. Yeah. These are good examples. Yeah. So, I mean, features are entirely up to you. The more features you have, it means the more you are explaining to your algorithm or you're adding in more information to the data you have. The data set will remain as is, but then you're telling the model, okay, look at the data set in this way and look at it again in this way, and so on. So features are extra information you give to your model. So the model becomes smarter. You're not, now you're telling the model like, you're looking at the data in this way, fine, but there's another angle to look at it, and that's the angle. Like, look at the month the person joined. You have that information, but perhaps you ignored it. But I need you to focus on the month part. This is important. So features put the weight on the model, and model will like start looking at it from that feature point of view. Now, if you take away the month part, the model will create its own understanding. But feature is a way for you to enforce the model, look at it the way I want you to look at the data. This is your control over the model. You can also aggregate information, the same table, and now, yeah, what you mentioned. You had the average, you had the mean amount, the max amount, and so on. So the same information, but you have expanded it with more. I would strongly encourage you to read up feature engineering in your own time. This is feature engineering is like the science in AI. The more feature engineering you can do, the better feature engineering you can do, the better programmer you can be, because it's all about features. It's all about parameters, how many features you add into the model, how good features you add in. So feature engineering, in my opinion, is like the true science in AI. Um, we have we have 5 more slides remaining. So these are very easy concepts. Now I'm going to talk about data in general. And these are things you should know about. I don't think you will work with these things, data wrangling, data mining. One time in your career, you might, but it's important for you to at least know what this terminologies means. So data wrangling is wrangling, like you take one type of data and you transform it to other and you combine it with more information. You have a lot of tools available which do data wrangling for you. Then there's another process called data mining. Data mining is basically, it's like mining, but you look at the data and you try to mine for the right information. It's like collecting or looking for patterns in your data sets. That will call data mining. And data warehousing. How many of you know data warehousing? Now, data warehousing is not taught in the universities. It's not something you would see on a daily basis. But there's a field called data warehousing, and what it means is that with so much data being building up, like an organization has lots and lots of people. If you have a 500, okay, 500 is a pretty big company. Even if you have a 3-4 persons company, you are using a Mac, they're using a Windows, you might be using your email messaging, they're using something else. After a while, you will start using 2 or 3 different applications, and you will realize that all these applications are living, they have their own data, they're living in their own silos. And now you have a need to combine all that data because you want to connect the client information you have with this employee information you have on that side. Now, this was a very small example, 2-3 person company, but take it to a 500 person company or a 1000 person company, and you have magnitude of applications and magnitude of data coming in, and you have production applications, and then you have data which exists in different silos. So what data warehouse does it combines all the data from different applications, brings it together. That's a dump of all the data. And then when you have the data coming in, you then build more applications on top of that one. This is called data warehousing. You will definitely learn more about this when you're in your professional life. But you should know what it is. This is a very nice pyramid, which I got from some lady called Monica, and she made this one on Twitter. She was sharing it, and it kind of shows you the life cycle of data or life cycle of data science. And the way this works is you always work with the collection part. You need to collect data first. That's step 0. You have to collect the data. You can just collect it by downloading a CSV file, or you can actually connect it by doing an integration with the sensors. And once you have done the collection part, you then move the data. And that means like moving it to a specific storage, moving it to your hard disk or something like that, or moving it to some other systems. Once you have it available on a specific server, you then have to explore the data. That will be the exploration transformation part. That's step 3. And then when you know what kind of data you have, you then enrich the data set with more information. That would be aggregation, label, and analysis, metrics, features, training, and whatever, something which we have already discussed. And when you're done with that part, then you learn from that data. Do some testing on the data, and yeah. And then, and only then, you can jump onto the AI part. And that's the part which comes at the end. And that's one of the reasons why we spend 85% of the time on this area, and then 15% or 5% up over there. So you have AI, you have machine learning, you have deep learning, but you have a new field. Well, it's not a new field, but you have a field called data science. And data science is the science of working with data. And it's very hard to define the boundary around this field, but it's the field, it's the art of working with data, and that is everything. That is data labeling, data optimization, data wrangling, data mining, data warehousing, and so on. So I think that was it. We are early. Do you have any questions? No. So we have a lab tomorrow, and then we have a lab Friday as well. In those labs, we're going to cover data, how to work with data inside Python programming language. So we have made a very easy lab. Follow that lab. And yeah, a few of you asked about the assignments having the wrong dates, and that was my fault. So I'm going to fix those. Assignments are not published yet. I just copied the whole course from the last year. So then everything was copied. So please don't pay attention to that one. I will fix that part. Thank you so much for today.